Okay, in our last video, we kind of introduced intermolecular forces, which is the force between molecules. And then we kind of talked about how it affects the state of matter that things like to be in, right? So remember, solids are just kind of vibrating in place like that. So they have a really strong attraction to the atoms around them, right? So they have strong intermolecular forces. That's solids. Liquids are, attracted to each other. They certainly stay together, but they can move around, they can flow past each other, right? And so they have medium intermolecular forces. And then gases just kind of fly around and do whatever. They're not attracted to any other gas molecules. So there's low forces of attraction between this atom and this atom, or this molecule and this molecule. And so there's no attraction, very little low intermolecular forces. That tends to make gases, right? And then just to kind of go into the definition some more, right? Intermolecular forces are attractive forces that occur between molecules, right? So if we look at these two water molecules, these lines here, those represent the bonds. That's a bond between an H and an O. This is not an intermolecular force. We would actually call those intramolecular, but nobody really calls them that. We just call them bonds. So what do we mean by intermolecular? It's a force attracting one water molecule to another molecule, right? So this kind of dotted line is representing that intermolecular force, right? It's showing that this water is attracted to this water here. This is kind of the same thing. This is a really bad drawing, by the way. The H's would not be attracted to each other like this, but just again, just to show you there's a different molecule. This would be like a bond in between inside the molecule, and then this would just be an attraction to other versions of those molecules, right? Showing the intermolecular force. So it's just an attraction, right? And last video we talked about how this is kind of like a magnet, right? This would be one separate magnet, this would be another separate magnet, and they're kind of held together by this invisible force. For molecules, it's not magnetism, it's actually electrostatics. It comes down to those charges that we always talk about, positive and negative charges. It's kind of keeping these molecules attracted to each other. Speaking of solids, liquids, and gases, another way we can think about those is melting points and boiling points. So remember that a melting point is the temperature at which something melts from a solid to a liquid, and a boiling point is the temperature at which something boils from a liquid to a gas, right? So we can kind of think about when are these going to be high or low? Well, think about it. If we have really low molecular forces through intermolecular forces, then the particles are going to want to separate a lot easier. And so the melting point is going to be lower, and so is the boiling point, right? So we can look here and we can try to see which of these compounds has the lowest intermolecular forces. Well, I see that out of all of these, H2 gas, it melts at negative 259 degrees Celsius, and it boils at negative 253 Celsius. That means that these hydrogens, as soon as there's any temperature at all in the room, turn into a gas. That means that they do not care about each other. They have no force of attraction from one hydrogen molecule to the next. So these would be our lowest IMF. Okay, so intermolecular forces are weaker when you have a low boiling and melting point. That means typically these are gases. Okay, so let's look at somewhere in the middle. So water. Look at water's melting and boiling point, 0 and 100. So water melts at 0 degrees Celsius and it boils at 100 degrees Celsius. So this is a lot higher than hydrogen. This tells us that water has some intermolecular forces, and water actually is fairly strong, at least for a liquid. So because it's a liquid at room temperature, which would be about 20-something degrees Celsius, we can say that it has like medium IMFs, right? It's kind of in the middle of some of these other compounds. And then which kind of compounds have the highest IMFs? Well, we just look for the highest melting and boiling points. Look at this stuff here. Whoa. So magnesium oxide, MgO. Notice that this is an ionic bond, metal and nonmetal. And then look at the melting point of this thing, 2,825 degrees Celsius. That's crazy. That is ridiculously hot. And then you can even boil it, but it takes 3,600 degrees Celsius. So this thing does not want to break away from as a solid. It wants to stay as a solid really, really bad. Why is that? It's because the magnesiums and the oxygens are strongly attracted to each other. They do not want to let go, right? They don't want to be pulled away from each other. So there's a really strong force holding these together, so we need a huge amount of energy and temperature to pull them apart. So this would be the strongest IMFs by far, right? And we could ask other questions. For example,